Hey guys, welcome to my kitchen. Why are we here? Well, we're going to start a new unit called kinetics, and I actually thought this would be a perfect place to start with it. So, what's kinetics? Well, it really has to do with the study of reactions, so we're going to be looking at reactions this time. And there's some pretty important stuff that we're going to talk about that we deal with every day. So when we talk about kinetics, we're really talking about why reactions do what they do. So it's important to be able to control reactions, not only in the chem lab, but also here in the kitchen or in industry, right? So what is kinetics? Well, really what it is we're looking at chemical reactions, and we're going to look at why sometimes chemical reactions happen and why sometimes they don't. We're also going to look at, in kinetics, we're going to look at why sometimes energy is released, all right, and why things give off energy. And we're going to look at why they absorb energy, right? And then we're also going to look at controlling the rates of reaction. Right? So sometimes we want a reaction to go really fast, but there are other times when we want it to go really slow, right? And sitting in my kitchen here is a pretty good example of both, right? So why would we want to slow down a reaction? Well, why do we have one of those things over there? Okay, so I got all this stuff in my fridge. Why is it in here? Here's a question for you. How long would this milk last if I left it out on the counter here? Probably not very long, right? Hour, two before it spoils. Well, what's spoiling? Spoiling is just a chemical reaction, right? It's turning in from just regular milk, and those proteins are changing in there, right? And it's making something new. We want the milk to last, so what do? Take it and we keep it in the fridge. Okay. Now, what is that going to do? Well, it slows that reaction rate down, right? Now, does it stop? No, we can't stop it because those particles are always moving, right? But if the particles are moving slower, that reaction rate or that spoilage rate is going to go down. Now, here's a question for you. Why do we have a freezer? Panda pause, anybody? Well, freezer does the same thing. It slows those particles down even more, right? And if we can slow those particles down even more, we're going to slow that spoilage rate down even more. Okay, so we can make things last longer in the freezer. Now, here's a question for you. If we put something in the freezer like, I don't know, meat or whatever we put in the freezer, will it last forever? Or will it spoil in that freezer? And the answer is that reaction still happens. It's just happening at a really, really slow rate, right? So it will happen, but putting it in that freezer makes it last a lot longer. All right. Well, why would we want to speed up a reaction? That's a good question too. Okay. Again, right here in the kitchen. Right? So if I'm going to cook something, all right, am I going to cook it at like, I don't know, room temperature? No. Okay, that wouldn't happen. All right, so if I cook something, I turn it on. Okay. I turn it on, all right, and we heat it up. Right now, let's say that I'm cooking something in the oven. If I cook it at, say, 250 degrees, it's going to take a lot longer than if I cook it at 350 degrees. What's the difference? Well, the reaction or the cooking, which is a type of reaction, right, is just going faster because that reaction rate is going faster. And we're going to talk a lot about why that happens and why and how we can control these rates, all right, and all these different things, right? And that's what kinetics is all about, all right? Now, I'm going to put you on hold for just 1 minute because I want to do another demo. I want to do a demo for you. I just can't do it in the kitchen. All right, it might blow up. Not really, but all right, hold on 1 second. All right, and we're going to switch to a different location. Okay, we've moved. We're now on my back deck. All right, it's actually beautiful out today. All right, so I want to show you something. So when we're talking about um, kinetics, all right, we're talking about how fast reactions go. We're also talking about whether a reaction happens or not. All right, and I want to show you an example of that. So this is what's called lycopodium. Right? And it's actually in powder form. And if you're to read the description of lycopodium, all right, it says something like extremely flammable, right? Potential of explosion, right? All right, well, that sounds pretty cool, right? So I don't know if you can see it, but here I'll bring it closer for you. Whoops, right? It's this brownish powder, right? Well, if it's so explosive, what should we do? Well, we should explode it. All right, so here we go. I got a match. Maybe I got a match. There we go. Let's get it going. Oh, it went out. Okay, I got it going good. Oh! Oh, here we go. All right, so let's see what happens when we put it in here. Nothing. Okay. So it's supposed to be highly explosive. But in this form, it actually isn't. So if we can change the form, and if I can change the form, all right, it will change its properties. Woo! Let's try that again. Oh, I put out the candle. Now let's try it. All right, here we go again. Ooh, I should have my glasses on. Trouble. Ooh. One more. Woo! Good one. All right. So what's the difference between when I put the match in and when I started sprinkling it over the flame? Well, what it does is it spreads out the powder. When it's in this solid packed form, it's not very flammable at all. But as soon as you spread it out, it becomes highly flammable. And actually what happens, right, this is called a dust explosion, right? So it's highly flammable in dust form, all right? And the reaction happens and it burns like crazy. But in this packed down form, it won't react readily, all right? So those are the things that we're going to be looking at in this unit, all right? And we're going to start with some basic kinetic stuff, and we'll start that right after this video, all right? So I hope you liked the introduction. You got to see my house a little bit, and we'll see you guys later. Have a good one.